So, um, at the core of things is just conducting like DFS. So, what comes down is that Operation Z is very much to do with visiting every single node. So, I visit every node, and now, and obviously until Operation X, is to do with like if say that we just one, that's when we actually start conducting the DFS, because I mean ultimately whatever the LeetCode rulebook is asking us to do, it's really comes down to this. I want the biggest island amongst all the islands. So conducting a DFS will allow us to actually find out what is like the biggest amongst all the islands. So you reach until one, you conduct a DFS over here. You reach as a one, you conduct another DFS. So how the DFS does actually come into play is it's gonna go through like these different operations. So operation E, where obviously you're gonna go 4 directions, and within the 4 directions you will always like reaches a form of like edge cases. So if say that like within the 4 directions you come our bounds until like this area, or you come to here, so it's both the negative and the positive our bounds, and obviously 0 is also our bounds. So we take consideration of that when we apply the operation E conducting the DFS. So it seems like each time that it does move towards the 4 directions, it's gonna also like record its value. So for this case, it term it as like a visit. So that the next time like it does reach to the next node, it's not gonna like revisit like the same thing. And another thing is this, that not only it does prevent it from visiting, I think there's like one more extra thing that's actually recording like the length, so that we know how big the island is. And then we actually do start moving the value to the say the next position, and for this case it's gonna come to here and then come to here, and eventually it has like a recorded length of this to be 4, and amongst like all the conducted islands, they're gonna find like the biggest island, and obviously it's gonna fall until like this island. It's gonna say like, oh, this island is like the biggest. And one more thing they actually do mention is that what if like you say that I'm gonna like conduct on every single guy, right? How do I know that like You say I gonna conduct a DFS over here. Am I gonna conduct like a DFS over here once again? The answer is no, because like each coordinate will be being input into, say, the visit set. So once you are being put into visits, they're not gonna like be able to calculate here again. So for this guy's perspective, this guy has already been visited, so I'm not gonna DFS here again. And to me, whatever they say here, it kind of makes sense. I just looking forward, like one day that I do actually look at that code and then say like, yo, this actually makes sense, and yeah, everything will just fall into place. And another thing that they talk a lot about is that the memory will be big O m times n. It's because, I mean, there's a possibility that they're gonna input every single thing to be inside the set. So make absolute sense. And the time complexity, the thing is this, I do forget about what the hell is time complexity. When you brought up about memory and then you talk about time, I suddenly get a very mixed idea. Maybe I bring in like the idea of like, say, Dota. So in the sense of Dota, it's like cooldown and mana cost, right? So are you saying that my cooldown will be big O m times n as well? Yeah, it kind of makes sense because I need to travel each of the place one times. Yeah, so I'll take that as that. Originally, I didn't think that like say that you want to find the biggest island. I didn't know that DFS does actually do record like the length of a SAS. So wow, that's something that I got to refresh onto, which is that these graphs of the character, say DFS, does actually calculate the length. And for this question, it does solve the problem for this. Because it does record the length. And one thing to take note is that you can't go diagonally. Whatever you can do, all you can do is like left, right. Basically, it's about vertically and horizontally. So yeah, so So yeah, everything comes to an end.